So we're looking at the annuity formula when the future value is equal to 0. So this formula is only going to work when the future value is equal to 0. And it is the present value is equal to the payments. And these are your monthly, quarterly, etc. payments. So it's the payments per period. The K is your duration. And it's the duration per payment period units. So if your compounding periods and your payment periods differ, it would be the duration per your payment periods. Then your effective interest. Effective interest. Now, one thing just to note, it's the effective interest per payment period. So you'll notice you convert everything to do with time to coincide with your payment periods. And that means that for your effective interest, if you had it as the effective interest per compounding period, you would have to find the equivalent effective interest rate per payment period. So it's an important thing to note and make sure that your effective interest here is per payment period and your duration is also per payment period units. So if your payments were in months, but your compounding was in quarters, you will need to convert everything to months to coincide with your payments. So we have an example of a loan of $55,000 is secured at an interest rate of 13% per annum compounded quarterly and will be paid back with equal monthly payments over 6 years. And it says calculate the value of the payments. So the first thing we're going to do is just see if we have a future value equals to 0 or we have a present value equals to 0, because that's going to dictate what formula we use. So here we have a loan of $55,000, which means we have a present value of $55,000, and we're paying it back. So we'll be paid back over 6 years. So that means our future value is equal to 0. And that, therefore, that tells us that the formula that we're going to use is going to be the one with PV as a subject of the formula equals to the payments. And then we're going to have 1 minus 1 plus IM to the power of minus K over IM, and all of that's multiplied by the payments. So that's the formula that we're going to be using. So before we start using the formula, let's write down all the other information that we know. So we have, it is secured at an interest rate of 13% per annum compounded quarterly. So we have the nominal interest rate here is 13% per annum compounded quarterly. And it will be paid back with equal monthly payments over 6 years. So the payment period is going to be months, and we're then also going to have the duration. K is 6 years, but it needs to be in months. Why does it need to be in months? Because it needs to coincide with the payment periods. So the payment periods are monthly. So we need to multiply that by 12 to get 72 months. And then we're like, oh, well, we also need to make sure that the interest is I-12. So we need to convert this to I-12. So let's go ahead and do that. Now, the first thing we're going to need to remember is that our J is equal to IM times by M, where M is the compounding periods. So from our nominal interest rate there, we can get I4. We can't get I12, we can get I4 because our compounding period was in quarters. So that's what we're going to do first. We're going to find I4. So I4 is equal to J divided by 4, which is equal to 0.13 divided by 4. Why is it 0.13? It's 0.13 because when we do in our formulas, we don't use the percentage as percent. We will be converting it to decimal fraction notation to use in our formula. That's why we have the 0.13 there. And now you may be thinking, okay, we have I4. How do we get this I4 to what we want, which is I12? And we have to think now and go, oh, well, we do know another formula. It's the equivalent effective interest rate formula. So that's IQ is equal to 1 plus IM, M divided by Q minus 1. Now, if that's new to you or you're unsure of how we got there, please go back to the videos where we discuss equivalent effective interest rates, particularly with the formulas, and you can recap it before coming back here. Okay, so now we can say, well, we want I12, so that's 1 plus I4, 4 divided by 12, minus 1. So now we're like, well, we have K, we have PV, we have I12. So we have pretty much everything we need for the formula. But what we're going to do first now is we're actually going to find our I12 and save it into our calculator. So we're going to use the storage button. And the reason for that is it just makes your life a little bit easier. You don't have to do it that way. You can just shove it into your formula right at the end and do everything at once. But if anything like me, I mess up very quickly on my calculator. So doing it in steps and using the storage and memory buttons is an added advantage because it breaks it down into pieces, but it doesn't bring in errors that you get as if you just wrote down the number and then put it back into your formula, because that's going to cause rounding off errors. So if you store it using your calculator's memory, it's going to keep it as if you were just typing it all into one formula. So we're going to store this into our calculator under a variable. And I just usually go alphabetically. So it'll be the A variable. Right. Now we have all the information we need. Let's go back to the formula and rearrange it so that we're solving for the PT. So let's just do that. So we have more space on our screen. We want the PT to be the subject of the formula. So we want PT equals. And we can do that by just dividing through by this term because it's all in one term next to the payment periods. All the payments, not the payment periods. So we have PT is equal to PV divided by 1 minus 1 plus IM minus K IM. So now we have our formula for the payments, which is what we were looking for. And now we can start subbing in the information. So we're going to have 55,000 divided by 1 minus 1 plus, and we're going to recall, so it's going to be variable A to the power of minus 72 divided by, and the variable that we're going to recall, so the recall A all and close brackets. Just note that when you put it on your calculator, it is going to just look like, this would just show as A, and this is just going to show as A. And let's just clean that up so you don't see all the mess. There we go. So now that's what we're going to put into our calculator. And if you put it into our calculator, we are going to get approximately equal to 1100.07. Why? approximately equal to, because it's actually going to be 1100.063956, but we're rounding off to 2 decimal places. So it's 1100.07. And just a quick note that the I-12, when you put it into your calculator and before you store it on your calculator, it's going to be 0.01071, etc. So you can see where you're heading. But now I am going to show you how it looks on like just an average scientific calculator. So you can just see how you can type it in, particularly when it comes to this part here, just so that in case you're a bit nervous, you can see it happening. So I'm just using a scientific calculator to do this when I do formulas. The scientific calculator I have does have fractional display, so just be aware of that, particularly if you're using a calculator that does not have that display. Now, just a quick reminder of how we can make sure that we don't have any artifacts from our previous calculations. We can say shift and then clear. And if you say shift and clear, it tells you, do you want to clear the setup, the memory, or all? We just want to clear the memory. So all our variables A, B, C, D, etc. is cleared up. So we don't, make mistakes and think we've done it when we haven't done it, and so on. So 2, and then we're just going to push equals to complete it. And then we just clear the screen there with the AC. Now we are going to first find I4 because we have the nominal interest rate and it's compounded quarterly. So we work out I4 first. And what I'm going to do, I'm going to keep storing my information instead of just bringing it across to the other formulas, just to show you a technique to make sure how you can keep all the data. So we want I4, so that's just the nominal interest rate in decimal fraction notation, divided by 4. So 0.13 divided by 4. And that gives us an answer. And I'm going to save this as my variable A. So shift STO A. Now we have I4, we need to convert it to I12. So we have that formula. So let's go through the process. It's open brackets, 1 plus I4, so recall A, close brackets, to the power of, and now we're going to say 4 over 12. Then we're going to push out of that, so we, on the bottom line, and we're going to say minus 1. And we get I12 in decimal fraction notation. So we're going to store this as well. So shift STOB. So we've stored it. And now we can go to our working out what our monthly payments are. So to work out our monthly payments, it's going to be the present value, which is 55,000 over. And then we're going to open our brackets because we have 1 minus brackets 1 plus IM close brackets to the power of minus K. So we're going to start by opening our brackets and then saying 1 minus. So everything on your numerator of the lower piece. Then we're going to have 1 plus recall B close brackets to the power of minus, and it's 72. Then we're going to close our brackets and then say divided by. Now you see the whole thing is over. So it's looking like your formula. If you didn't have the brackets there, it would have just taken the last piece as over. So just be careful about that and make sure your brackets are accurate. And then we're just going to recall B. And then we're just going to go to the end year. And the end year is the top one. So we're going to say equals. And there we go. We have our answer is 1,100 and 0.63956. We round it off. That's why we get 1,100.07.